Alright guys, now we're going to do chapter 9, section 7. It's called variations. Not my favorite chapter. Not my favorite section. All the stuff we've been doing till now is actually kind of useful. This is just particulars of polynomials and of rational expressions. So we're going to go over it kind of fast. You don't have a ton of homework on it, but I just want you guys to understand the concept, okay? So variations just means that your quadratic equation doesn't necessarily have y equals x. It's some type of variation of that. So it can be y equals 3x, or y equals x over 3, which is the same as 1/3 times x. So you're just telling me how y changes or how y varies in response to x. Now, if it varies like this, if your equation is y equals x, that's a direct variation, right? Every time x goes up by 1, y goes up by 1. Every time x goes down by 1, y goes down by 1. So that's an easy one, right? You can also have direct variations, but it's going up by some certain number. So you can have y equals k times x. Now k is just kind of a placeholder that we're putting in there for a number. So that just means that y goes up at the same time as x does, but not at the same speed, not in the same ratio. So you could have y equals x over 2, right? That's the same as 1 over 2x. So see, that's your k. So that means that every time x goes up by half, y is going up by 1. So it's still a direct variation, but your slope's not going to be 1, right? It's going to be a little bit different. You can also have y equals 3x. Again, it's a direct variation, but every time x goes up by 3, y is going up by 1. So again, you're not going to have a slope of 1. Okay? So that's all that means. Variation just means how is your y changing in relation to your x. So we're going to do an example of direct variation, and we're actually going to do one that's kind of applicable, especially for people that are taking geometry next year. Go to example 1, which is on page 380, and it says the area of a circle varies directly as the square of the radius. We're going to use y and x because it's easier. So y varies directly. So directly just means you have a number there. We don't know what the number is. With the square of the radius. So it's not varying with x, it's varying with x squared. So it's still varying directly, but again at a different ratio because it's changing, x is changing exponentially and y is just changing linearly, okay? So they want us to write the equation of this variation, which is that. Then they want us to give what the constant is, okay? So we know what the constant is, right? What's the formula for the area of a square? It's area equals pi r squared. So this is the equation. If you had no information, never taken geometry in your life, had no idea how to calculate the area of a square. Y is varying proportionally to the square of x. But we know geometry. We know that this area of a square is of a circle is pi r squared. So we fill that in. A for y, r for x, and pi is rk, or r constant, okay? Example 2 is similar to that. Again, you have something varying directly. Now in that case, they're actually giving you a value for x and a value for y, and you're plugging them in order to find k. In this case, we knew what k was. Now we're trying to find it. So let's do that one real quick, okay? It says y varies directly with k. That's what we have. Now they're giving us a little more information. They're saying y is 8. I'm going to plug that in. When x is 1/2. And then they're saying find y when x equals 4. So how are you going to find that? Well, you have to figure out what k is first. But that's really easy because we already have 2 values. All we have to do now is bring this 1/2 over to this side. So it's 8 divided by 1/2 equals k. So remember, when you're dividing, you just flip the fraction. So you're just saying 8 times 2 equals k, which equals 16, right? That's also what the book got. So now we know that that's our constant. Well, we have x, we have a constant, we can find y. We say y equals 16 times 4, which equals 64, which is what the book got. Okay, so it's just plugging in letters. Really, it's kind of like doing word problems with rational equations. Now, sometimes the variables aren't going to be directly related. Sometimes they're going to be inversely related. does inversely related mean? That means that they change opposite each other. So one's in the numerator while one's in the denominator. As x gets big, y is going to get small. As x gets small, y is going to get big. What other types of variations do they have? That's called inverse variation, and the example they give is gravity. You guys can deal with that when you get to physics, okay? So let's look at one of these examples. We're not going to do, we won't do 5 yet. Let's do examples 3 and 4. Let's look at them real quick, okay? So example 3 says y varies inversely. So that means that if y is in the numerator, x is going to be in the denominator, okay? As x cubed. So let's erase these guys. We had x squared when we were dealing with a circle. Now we have x cubed. So y is inverse. So I could say k times 1 over x cubed. I'm just going to put k over x cubed. Then they say y is 16 when x equals 2. Now they want to find y when x equals 8. So we can't do that straight off the bat. However, we can plug 16 and 2 in order to get k, and then we can find y for any value of x they give us. So we can say y is 16 equals k over, let's just go ahead and do the math. 2 cubed is just 8, right? Remember, bring the 8 over to this side. 16 times 8 is, Anissa, what's 16 times 8? 16 times 2 is 32. 64, 128 equals k. Let's make sure that's what the book got. Yes, 128 equals k. Now we have a value for k. Now we can find y, right? We just say y equals 128 over, and then we have the value for x, which is 8 cubed. So y equals 128 over 8 cubed is 8 times 8 is 64 times 8. 64 times 64 is 128. All right, let's just say what the book has because I don't want to do that math in my head. 512. 512. Of course, we can simplify that. I'm not going to do that math in my head either. The book says that's 1 over 4. Okay, so you're just finding the constants by which they're varying, and then you're able to write an equation. You could graph it if you wanted to, because then it would be in the form of y equals mx plus b. All right, now the last thing they have is when you have combined or joint variation. That means that you have a third variable in there, and that third variable changes with x and y. So we're going to bring z in again like we did when we were studying three-dimensional points. And we're going to say that z varies jointly with x and y. So you can have z equals k times xy, but you might also have z equals k times x plus y, or x over y. You can have lots of different changes, okay? But you're going to have a z that's changing with an x and a y. And the only example we have for that is example 5. And it says, write the general equation for this statement. Y varies directly, so that means you have y equals, and it's going to vary directly, so there's going to be some type of constant in there, we're just going to call it k, as the sum of x and z. Sum of x and z, but we're not done. Then it says, and inversely as the square of x. So inversely means if y is at the top of the fraction or at the numerator, the x squared is going to have to be at the denominator because it says varies inversely as the square of x. And then if we were going to go further and they said some value of y when x equals something and z equals something, we could find k, we could plug it in, and we'd get some type of equation that we could reuse. But I don't believe that there's even any like that on your homework, okay? So all you're doing basically is turning the word problems that they're giving you into some type of equation. Make sure you use the letter k for your constant. And once you find k, using that information to find more answers, okay? So your homework, pages 382 to 383, 1 through 3, and 9 to 11.